These are the notes for AP Calculus on the topic of real-world rate of change problems using the graphing calculator. So this first one gives us bees enter a beehive at a rate, which is just another word for the derivative, modeled by the function E of t. So that's the rate they're entering the beehive. And bees leave the beehive at a rate, another word for the derivative, defined by L of t. And notice E of t and L of t are both measured in bees per hour. That's another clue of the derivatives because it's something per something, in this case bees per hour. If it was just the amount of bees, it would just be bees. And then notice t is measured in hours since noon. So noon corresponds to t equals 0. And these functions are valid between noon, which we just said is t equals 0, and 6 p.m., which, notice if it was 6 a.m., that would be 6 hours after noon. So 6 a.m. would be beyond 6 hours. 6 p.m., though, is just 6 hours after noon, so that would be t equals 6. And then it says at noon, there are 800 bees in the beehive, so that's giving us an initial amount, which is not always at time 0, but in this case it is at t equals 0. So it says how many bees have entered, so we're just focusing on how many have entered the beehive over the 6-hour period from noon, which is time 0, to 6 p.m., time equals 6, and give your answer to the nearest whole number, because we're talking about bees here. Anytime we're talking about bees or people or something like that, that decimal part doesn't make sense, you would round to the nearest whole number. Or other things, you would go to the thousandths place. So this is like an initial plus change, except we're not focused on the initial at all here, just how many have entered, and we're not focused on the overall change, just the amount that are entering, not the amount that are leaving. So this would be the integral from 0 to 6 of just E of t. dt. Okay, so now let's go ahead and enter these in. I'm going to show it on both calculators, both the TI-84 and the TI-Nspire. So for the 84, I have an older one, some of you guys might look a little newer than this one. So here we go y equals, and then we have to enter in our two functions here. So the first one we have is 20 plus 3, and then use the exponent button right here. And then we have to have this whole thing in the exponent, so put parentheses around it. And 0.1, or I could just put 0.1. And then we have t here, but in our calculator, we're using x instead of t. So it's like e of x. So it'd be x and then squared, and then a closed parentheses on the exponent. And then go down for y2. We have 15 plus 18, and then we've got sine. So sine is right here. And then inside of sine, did the open parentheses, we have pi t over 8. So pi, it goes second. This is pi. And then instead of t, again, we're going to use x divided by 8. Close parentheses. Before we graph it, though, let's change our window size. Oh, one other thing to make sure, especially when you have trig functions here, when you hit mode, make sure you're on radians, not degrees. Otherwise, I'll throw off all the answers on the trig function ones. So just if you're not, if it's on degrees, just go back to radians and highlight by hitting enter on there. So it's on radians. Okay. And then before we graph it, here's y equals again. We'll hit window. And then notice it's usually on these going to tell you what the x minimum and maximum. In this case, it's valid between noon and 6 p.m. So this becomes our x minimum on our window size, and this becomes our x maximum on our window size. So 0 will be the minimum, and 6 is the maximum. Now the y-min and max are not going to tell you. So you just have to kind of look at the numbers in here and try to guess and then adjust it from there. So the numbers aren't too big here, but they could look like bigger than 10 and negative 10. So I'm just going to go, we got 15, 18, 20, and then 3 to this power. I'm going to try negative 100 to 100 to start with. And then I can adjust it from there for my y-min and max. And then once you have the window size there, we'll graph it. It's going to graph in the order you typed them in. So there's E of t. And there's L of t. So I can see them both. Looks like I don't need quite as high as it. Maybe I'll change it to like 80. And there's all this wasted space down here, so I'll change that too. So I'm going to hit window again. There's not an exact values here, just so you can see the graphs a little better. So you get y max, I'll make that 80. And then I want to make it something negative for the y minimum so we can see where the x-axis is, so I'll maybe make it negative 50. So and then regraph it. Delete that 0 there. As long as we can see what they kind of look like in that interval, it's fine. And there's L of t right there. So that gives you a little bit of a picture of what it looks like. All right, so now that they're entered in, now I can enter in this integral. Then I'll do it on the Inspire right after this. So to get out of the graph, you just go second, quit right here. And then anytime you need a definite interval, you hit the math button. And then go down and choose number 9. Function integrate. Now mine is the old one. It kind of looks like this. So on the newer ones, I'll write it here on paper what it's going to look like here. By now a lot of you guys probably have the newer 84s, which are actually more user friendly. It's going to, instead of FNINT, it's going to look like this with a box there, there, and then a DN box. So what it's going to look like on yours, if you have the newer 84, is you're going to put 0. It's just like it's written on paper. You're going to put 0 right here in your lower limit, 6 right here. And then in order to get E of t, I'll show you how to get that in just a second. It's going to actually be the, that's our y1 is going to go right here. And then dx. On mine, it's a little older, 84, so it doesn't look quite as user-friendly, but we're putting the same information in. If you have an older 84 like mine, or a 83, TI 83, it'll look like this. So what I have to do instead of the lower and upper limits first, I have to put y1. The way you get y1 is you hit the vars button, and then hit the right arrow y variables, and the number 1 function, and then choose y1. And then here on the older ones, you have to put a comma. On the newer ones, you don't need a comma at all. And then I have to put what the variable is, x, where you put it right here after the d, so it's dx, and then comma. And now I put the lower limit upper limit. So 0, comma, 6, and then close parentheses. So that's on the older ones. The newer ones will look like the same information, just in a different place. And then hit enter. And we get 167.821. Normally you'd round it to the thousandths place on most answers. 167.821. That's what we get. But here, since we're talking about B's, notice it started out as B's per hour, but we integrate it, gets rid of the per hour. So you'd round it to the nearest whole number. So in this case, that would be 168 B's. That would round up. All right, now let's look at the Inspire, how we put this all in. So for the Inspire, I would recommend not using the scratch pad because you can actually save things and come back to them if you need to, whether it's homework problems or on the AP test. So you don't have to retype everything. So it makes it a little easier. Just go to New Document, Enter, and then Add Graphs. And then if you ever want to save it, you go Document and File, Save As. You can give it a name and then come back to it later without having to retype everything in. But for ours, I'm going to just type in the functions here. So it's 20 for F1. After I hit the graphs, you can enter 20 plus 3, and here's the exponent button right here. And again, you can put 0.1. And then again, instead of t, we're going to use x. So x, and then squared is right there. And then hit the down arrow to get down to F2. And that's our L of t, which is 15 plus 18. Sine is right here. the trig button, and then we want, if you want to make it look like a fraction here, you can use the fraction button next to the 9. And then we want the pi, which is on the pi button right here. And then instead of t again, we're going to use x, and then divided by 8. And then when you hit enter, it's going to graph it here. But again, we need to change the window size, so let's make it the same as we did on the 84. So the menu, remember it told us, you go menu, window, window settings. It told you the lower limit was 0 at noon, and the upper limit was 6 p.m. And the Y minimum here, remember we made it negative 50, and the Y maximum 80. And then OK. Now we can see the part of the functions that's valid for our problem. And now, to get our integral, doc, insert, calculator. So now it opens up 1.2. And then to get the integral button, you just hit right next to the 9 here. And you can see this one right down here. It looks like the integral. And it looks just like the new rad4s. You put the lower limit 0 here, upper limit 6 here. And then to get, in our case, it was E of t was F1, so hit the bar button. F1, and you just need to put x, F1 of x, and then dx. You get the same answer. All right, now let's go into part B. Now part B asks for what is the average number of bees that leave the beehive over the 6-hour period from noon to 6 p.m. So again, we have the interval, t equals 0 to t equals 6. But we want the average that leave the beehive, okay? So anytime you're doing the average, you start off with 1 over b minus a. In this case, here's our a and b. 1 over 6 minus 0. And then it's the integral of whatever you're finding the average of. In this case, from 0 to 6. And we just want the average bees that leave the beehive. So it's just going to be E of t. L of t. If it was the average bees that enter, it would be E of t. If it was the overall average rate of change of the bees, it would be E of t minus L of t. So when we put that in our calculator, go back to the 84. So we can first put parentheses 1, 6th out in front. And then math, number 9 again, function integrate. And again, mine's going to look like the older ones. The newer one's going to, again, look more like this, except it's going to have y2 here instead of y1. So mine have to go vars, y variables, y2, comma, x goes here for me. On the newer ones, it goes right next to the d, comma, lower limit 0. On the newer ones, the lower limit goes right here, and then comma, upper limit 6. And again, the newer ones, you don't need commas at all. Close parentheses. Just make sure you have the 1/6 out in front. And we get 28.041. And averages can always have decimal parts to them, so no need to round it here, unless it specifically tells you to, but usually it won't on averages. So that would be bees per hour. And then on the Inspire, that would be, you put the fraction out in front, 1/6. And then integral 0 to 6. And then it would be F2. You get the same answer. All right, now let's take a look at part C. This one takes the most work here. And it says from 0 to 6, so that's your x min and max. And what is the greatest number of bees in the beehive? So greatest is another name for maximum. And when it doesn't specify, it's talking about the absolute maximum here. justify your answer. So, whenever you're trying to find the absolute maximum, absolute minimum, you have to find relative mins and maxes. And you do that by taking the overall derivative and finding the critical numbers. In this case, though, there's two components to derivative, E of t and L of t. And the one that goes first is whatever rate's increasing it. So they enter the beehive at this rate. That's increasing the bees in the beehive. And they leave the beehive at this rate. That's decreasing the bees in the beehive. So in this case, E would go first. So it'd be E of t minus L of t. And on most of these applied ones, you're not going to ever have to worry about where it's undefined in this interval. So you just have to see where it's equal to 0. And so the way we do this on our calculator, I'll start with 84. Go back to y equals. And now what we want to graph is the overall derivative instead of separately. So what you can do is de-highlight this by putting the cursor on the equal sign and hitting enter. And then go down, do the same thing for y2, de-highlight by hitting enter on there. So they're still in your calculator, but it's not going to graph them anymore. And now for y3, since we want E of t first, that's y1. So vars y variables, number one function, y1. And then minus, for y, L of t is y2, so hit the vars button. Right arrow, y variables, number one function. And then choose y2. And now we want to see where this is 0. So you can go second, calc, number 2 zeros. And now what it's graphing is the overall derivative, E of t, the rate they're entering minus the rate they're leaving the beehive. And there we can draw a number line based on this, okay? So on paper, let's still draw that here, even though we're using our calculator. And remember our window size here was just 0 to 6. So that's where it's really important here to have your window size correct. So you only see the part that's valid. And what we're looking at is E of t minus L of t. That's our overall derivative. And we're looking at the y values because this is the graph of the overall derivative. So you can see the y values on our graph. We go back there. Start out being positive here until some value a. Then they're negative below the x-axis till b, and then back to positive. Positive, 0, negative, and 0, and then back to positive. And then I'm just going to call these capital A and then capital B. So this tells you the number of bees in the beehive, since this is overall derivative, would be increasing because the derivative is positive, then decreasing, and then back to increasing. So if we sketch a little graph of that, the bees in the beehive increasing, then decreasing, and then increasing, that shows you where the maximum, absolute maximum could be is either at A or at our endpoint of 6. Or if it asks for the least number of bees in the beehive, the absolute minimum, then it would either be at 0 or B. So we have to find where A is exactly, and that's where we use our calculator. We can write down what it is on paper. So again, I'll show this on the finish showing this on the 84, then I'll show it on the Inspire. So we ask for the zeros left bound. We just have to move the cursor to the left, or you can type in of this 0 here and hit enter. It puts a little triangle up here so you can see where your left bound is. And right bound, just put it a little bit to the right of that 0 and hit enter. And then guess, you just have to move the cursor in between them and hit enter a third time. As long as it's between the left and right bound, and that's the only 0, it'll find the correct value. So there it tells you it's 0.87. Again, we have to be accurate to the thousands place, so that'd round to 9. Or you can write the whole thing if you want. It's important to write on paper, otherwise only you and your calculator will know what it is. And we already know this is at 6. And then the way you store that in your calculator, so we never have to type it in and don't make a mistake that way either, is you go second, quit. And on most of them, you can just hit the store button. That puts the answer that we just got for the x-coordinate, and we can store it as alpha and then see the green A right there, or whatever color it is on yours. And now I'll show you that value, and it's going to store in our calculator as alpha A. So anytime we need it, we can just type it in as alpha A. Or if the answer didn't come up right away, if you have an older like 83, you could first hit second ANS for answer, and then store, STO, and then alpha A. So that's in our calculator as A. And now let me show you guys on the Inspire how to do that. So on the Inspire, just go back here to 1.1 and then hit the tab button to get back to your functions. And then on most of them, you're going to uncheck the box, or if you have an older Inspire, you have to put a slash through the eyeballs by checking on here so we don't see it. And then go down to F3, and again we want E of t minus L of t, so that's a var F1 of x minus var F2 of x. Okay, and then it graphs it. And then to find the 0 here, again we already drew our number line, we want to find A right here. Go Menu, Analyze Graph, 0. Lower bound, you just have to move this vertical line and click to the left of it somewhere. Upper bound, just click to the right of it, and that's it. It'll find it for you. And then the way you store it, just click on this so it just highlights the x coordinate, and then hit the var button, store variable, and then choose a letter A. You don't have to hit alpha on this one, and enter, and it puts it in bold, and you see it's linked to A. All right, so now let's figure out which of these is actually going to give us the greatest number of bees in the beehive. So it doesn't give us something to call the function for the amount of bees in the beehive, so you can call it whatever you want. I'm just going to use, I'm going to call it B of t. So I'll just compare B of A with B of 6. So both of these are set up as initial plus change to see how many bees are there to start with, and then what's the change going to be. So the initial here on both of them, we haven't used it yet, but is 800 bees at noon at time 0. So it'd be 800 plus the change comes from the integral. The lower limit comes from wherever the initial is. Oftentimes it's 0, which in this case noon is 0, but not always. And we want to see how much it changes from 0 to A. And then here, unlike these two, to figure out the overall change, not just the entering or just the leaving, we have to use both of them, just like we did here, E of t minus L of t. Again, the one that goes first is always the rate that's increasing it. The one that goes second is always the rate that's decreasing whatever it is. So we'll put that in our calculator in a second. And then B of 6, again, would be 800 plus integral from 0 to 6 E of t minus L of t dt. So finally, let's see how we can enter this in both of our calculators. Let's start with 84. So now we can go 800, that's our initial, plus math number 9 for the integral. And again, I'll write here, the newer 84s are going to look like this. 800 plus, it's going to be that same format, integral and on the newer ones, what you're going to do is put 0 here, your lower limit, and then you can use alpha A, because we stored that in our calculator there. And you could put y1 minus y2, or we already have in our calculator as y3. And then dx. X goes right there. All right, so on mine, it's going to have the same information, just a little bit less user-friendly format. So I have to first put y3, so you get vars, y variables, number 1 function, y3. Then I have to use a comma, and then I put x right here, comma, lower limit 0, comma, upper limit alpha A. Hit the alpha button A, and then as long as you stored it, this way you never have to type it in. And we get 802.596 And then we just have to compare that with b of 6. So a little time saver, since we have to do another integral. Whoops. Sorry about that. Another integral. Back to the calculator here. I clicked on the wrong thing. So you can just go second entry, and then on the enter button, that'll take you right back to here because we want another integral almost identical. The only thing we have to change is this upper limit. Instead of a, we want that upper limit to be 6. So that way you don't have to retype the whole thing. That's almost exactly the same. And then we get 799.573. And in this case, the maximum would be around to there, so would be at time A, which is 803. So we can word our answer, and then I'll show you how to do it on the Spire. The greatest number of bees in the beehive is 803 bees at t equals a, units for time here are hours. And then to justify it, there's a couple ways you could do this. Since one helpful reason for making up a function here that wasn't given to you is to make the justification a little easier. Then you can just say since b of a turned out to be greater than b of 6. If you did make up a function, then what you could say, you'd have to write this whole thing since the 800 plus this integral is greater than 800 plus this integral. That would also be correct. And then on the Inspire, the way you do that is you just go click on 1.2, so you're back here, and then 800 plus, integral's right next to the 9 here. 0, look like the new radial force, A, and then this one was F3, so var F3 of x dx. Whoops. X goes right there. Okay, and we get the same answer there. And then if you don't have to retype the whole thing, you can just highlight it, and then you can go Control C, copies, just like on the computer, and then Control V is the paste. And then all you have to do is change here this upper limit to 6. You get the same answers. All right, last part on this one here is the rate of change in the number of bees in the beehive increasing or decreasing at 5 p.m. So 5 p.m. is 5 hours after noon, so that would be t equals 5. And notice it doesn't say is the number of bees in the beehive increasing or decreasing. If it just said is the number of bees increasing or decreasing, you would just find E of 5 minus L of 5. But it actually asks is the rate of change, that's another name for the derivative, in the number of bees increasing. So we want to know is the derivative increasing or decreasing. And the derivative is E of t minus L of t. So we want to know at one specific time, basically, is E prime of 5 minus L prime of 5, is that going to be positive or negative? Because that's the derivative of the rate of change of the number of bees. Okay? We'll see if that's positive or negative. So you could do this by hand, take the derivatives by hand, and then plug in 5. But on your calculator, there's an easier way to do that. It's called the numerical derivative. So the way you can do this here is just hit the math button and then go down to number 8 and deriv. Again, mine's going to look like the older one. The newer ones have a little different format to them. So the newer ones are going to look like this. And so on the newer ones, where you're going to put the x's right here, you're going to put what you're taking the derivative of here, which you could put as y1 minus y2, or since that's the same as y3, you can just put y3, and then x equals, we want it specifically at 5. So on my older 84, I'm going to do the same thing, just going to look, same information, just different format. I have to put the y3 first, or again, you could do y1 minus y2. So vars y variables, number one function, y3. And then I have to put a comma and put the x next, comma, and then I put the 5, what we're plugging in. And we get 19.831. Now the units here, notice E and L were already in B's per hour. So this is the derivative of that, so this would be B's per hour squared. And the key on that is because the derivative of our rate of change, the derivative of the derivative, which is kind of like the second derivative here, the key is it's greater than 0. So that means, and I'll show that on the Inspire in just a second, you can say the rate of change in the number of bees in the beehive is increasing I should have said at 5 p.m. And then your justification would just be since E prime of 5 minus L prime of 5 is greater than 0. If it was less than 0, if it was a negative answer, then it would be decreasing. And then let me just show this on the Inspire real quick. So here, to get the numerical derivative, there's different ways, but I think the easiest way is to go menu, calculus, derivative at a point. The variable's x. The value we want to plug in is 5, and we want the first derivative. And it looks similar to the newer 84s, except they already put the x and the 5 in here for you, and then you just have to put what you're taking the derivative variable. You put f1 minus f2 or just f3 of x. We get the same thing. And that concludes the notes for AP Calculus on the topic of real-world rate of change problems.